Hello and welcome back to another video. In this problem, we're asked when a camera flash goes off, the batteries immediately begin to recharge the flash's capacitor, which stores electric charge given by the function q of t is equal to q naught times 1 minus e to the negative t over a. The maximum charge capacity is q naught and t is measured in seconds. So what we're going to do here is take the function, right? So we have q of t equals q naught times 1 minus e to the negative t over a. And to find the inverse, we have to swap q of t and t. So q of t becomes t equals q naught times 1 minus e to the negative q of t becomes q inverse of t over a. So the first thing we can do is divide by q naught on both sides. This cancels. We're left with t over q naught equals 1 minus e to the negative q inverse of t over a. We're going to subtract 1 from both sides. T over q naught minus 1 equals negative e to the negative q inverse of t over a. Multiplying by negative 1 on both sides, multiplying everything by negative 1. This just disappears because it's just a positive sign. Now we can turn this into a logarithm because we have an exponential here. So this is log base e of this side, 1 minus t over q naught, equals negative q inverse of t over a. Bringing this up here. If we divide both sides by negative a, negative signs cancel, a's cancel. And actually, we're going to have to multiply by a since it's in the denominator. So ignore this. This a cancels with this, and the negative signs, it doesn't matter. They just cancel anyways. So multiplying by negative a this time, not dividing. We get the inverse of q equals negative a times log base e is ln of 1 minus t over q naught. What does this mean? Well, we are in the original function representing charge in terms of time. So here, this is time in terms of charge. So t here in this new function equals charge, and q inverse, this inverse function, is the time at which this charge occurs. So how long does it take to recharge the capacitor to 90% of capacity? We're looking for the time q at when the charge is 90% of capacity, 90% of q naught. So we're taking this function and we're measuring it at 90% of q naught. And a here is 2. So this is negative 2 ln of 1 minus, we're plugging in this value, 0.9 q naught divided by q naught. The function at this value is negative 2 of ln times, so q naughts cancel, 1 minus 0.9 is 0.1. The value of the function here is negative 2 times the natural log of 0.1. So this is the time it takes to recharge the capacitor to 90% of capacity if a is equal to 2, based off of this original function and finding its inverse, q inverse of t equals negative a times the natural log of 1 minus t over q naught. So this is a and this is b.